Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Harman Kardon 330A. It's kind of a rare beast. These are the first 330As. I think Harman Kardon made 4 versions of the 330. They made the 330A, they made the 330B, which is pretty much identical in everything except for name. And then about halfway through that production run, I think they revised the 330B, and they made an updated version of 330B, and there's a different service manual for that one. It made quite a few changes. And then at the end they brought out the 330C, which to my opinion is the best of them all because it's the most refined and it's most fun to listen to. But this is a client unit. He wants it fixed. He brought it to me about a month ago now. It's been sitting, and it's a good thing he leaves me notes. It says scratchy volume pot. Okay, well that's a given. Tape input, the monitor switch cutting out on one channel. FM stereo light stays on and doesn't tune stations very well. Okay, I can pretty much guess right now that we're going to have problems with capacitors in the tuner. That's probably the big part of what goes wrong with a tuner at this age. Now he had this loaned out to one of his friends that was getting into vintage audio equipment and doing vinyl, and he was using this receiver as a for vinyl, but they weren't having very good success with it because I think because of the faults with the volume pot and the switch or the connector or whatever. I think he was having troubles with it and it wasn't working very well. Let's check out the phono stage as well, make sure that's 100%, and we can turn it on right now. Let's see, we got speaker 1 on. Okay, counter's off. Okay, let's turn this on. We're on. Turn on my signal generator. Okay, I got my signal generator on, and let's turn this to auxiliary. Turn this on. Okay, no delay in the coming up of the volume. Okay, scratchy left channel. Definitely scratchy left channel. Okay, that's working. Phono. And some background hiss, which is normal. And stereo. Stereo light's on. It's flickering. Now I got an antenna pumping in a good strong signal on the back. It's picking up all the stations, and it seems to be working. This station is mono, and the stereo light went out. So it seems like the stereo light's working. It's just being activated by background noise. Actually, the tuner is working better than I expected.
Let's get our first afternoon look at the roads.
Yeah, right now things moving.
Getting a 10 on the meter.
Third media radio station, CKEA FM.
I think the FM's working great. I think it just needs a good antenna. It's picking up everything and it's doing it well. Getting good separation. Probably needs an alignment, and like I said, it's going to need capacitors as well. You know that. That's a given. So anyways, let's have a look inside. Let's look at the back first. Before I go any further, I want to test this tape monitor. So I got a signal back on the tape monitor now. We only got one channel. Yeah, we got a dicky switch. just on the one side. I don't know, it's a switch or I don't think it's a connection. It's a switch, definitely. Yeah, that switch needs a good clean. Here's the back panel. Got 3 inputs: phono, tape auxiliary. That's second, and then we have the tape monitor input. This could be used as auxiliary or tape input. And then we have 2 tape outputs, so you could run 2 decks if you had to. Main preamp out, main amp in. That's a nice feature to have on a, especially on a small machine like this. You can up the power really easy. You just put on any old power amplifier and let it rip. Speaker protection fuses. Got left and right output twice. Main power fuse. It says 2 amps. A switched outlet. We got a bar antenna and our FM input. And we got a connection for AM long wire if you wanted to go that way as well. These speaker fuses are sometimes not correct. Let's check. 3 amps. That's not good. That's supposed to be 1.5. Okay, let's try the other one. First thing that happens when these fuses pop is they put the wrong value in. 2 amps. Okay, well, it's getting better, but it's not good enough. We'll fix that. Okay, first look inside. Oh wow, looks really nice. It's nice and clean. Pretty cool. So this is all power amplifier here. This is our AM section, I believe, and then this would be our FM IF strip here, multiplex, phono stage, and a cute little power transformer that's marked HK330A. Alright, so I'm going to get started on recapping. This one of the things about this is it has capacitors on the outputs, and these ones here are 1000 microfarad, which is fairly typical. This is the main filter cap for the power supply. These 2 caps are output DC blocking output capacitors on the speakers. So you can't measure for DC offset on the outputs because there will be, because these leak all the time, and there's no way to. But these are Elna caps, Sanpo. There is no Elna caps in this. Very clean. Very nice to work on. Okay, let's look at the bottom. Okay, looking at the screws of this thing, looks like somebody's been into her quite often. So this thing here is cross-threaded and stripped and sticking out. It's supposed to be a M4 screw, but it's all mashed on the end. So I'm expecting to see some other work that's been going on. So I'm expecting to see some surprises from the condition of these screws. They're pretty mauled up from, this one's kind of cross-threaded as well. Okay. Took the screws out earlier. Not much going on here, just the bottom of all the boards, all the interconnect wiring. Everything looks untouched. Considering how many times somebody's been into this thing, I don't think anything's been replaced. I don't see any butcher jobs or anything like that. It looks very clean, very very factory. Okay, so we have more power supply stuff up here. It's a bridge diode. There's switches. Switches are easy to get at. Here's the switches. Let's remove the front panel, and then there's 2 screws on the front of each switch. Alright, so I'll get started on recapping, and I'll bring you back in when I find something. Okay, I'm just working my way through circuits and capacitors. There was 2 capacitors on this terminal strip. Both of them went to ground. And then there's just some resistors here. There's some dropping resistors and there's some bleed resistors. Now these are all carbon comps, and they are all out to lunch. So I pulled this one out. It's what this is, 680 ohms, and this one measures high. They all measure high. This one's at 735 or so. So that's out of a 10%. Pretty sure that's out of 10%. I'm going to replace it anyways with a 1 watt. Now these resistors here, these 2 here, if you look at the color codes, I don't know if you can see them, I'll zoom in, they look like, to me, they look like gray, red, red. And they both look like that, gray, red, red. But actually that's a brown instead of a red, it's a darker red. So it's 820 ohms. These are just bleed resistors, so I'm not really worried about them, but just for example, this one is supposed to be 820 ohms and it measures 1.74K. This one here measures 2K, so it's probably double, more than double what it's supposed to be. This one here is supposed to be 270 ohms, and this is a dropping resistor, and it is measuring 295. So that's right on the edge of the 10% tolerance. I'm going to replace all these resistors, all 4 of them, and then we'll get some new caps in here, and then we're going to be good. So far the caps are holding up really well. For example, these Sampo Taiwan caps, they are really impressive. They are holding their value and they're not dried up. See lots of these. I'm going to pull out another one. Here's another one. Pretty close to the tolerance, and they're holding up. I'm really surprised. Even this one here that looks really bad is doing good. Let me try this one here just to give you an example of what it should say. Let me get this connected. Okay, we are connected, and I have to go over here. And this is at 976 microfarads. Dissipation factor is 0.07, which is good. Q is over 13, which is good. And it has 100 milliohms ESR, which ain't great, but you know what? It ain't bad either. I've seen a lot worse. So caps are holding up. Okay, there it is, all rewired with new caps, new resistors. Let's just solder this up, and then I can move on to something else. Yeah, anytime I see a carbon comp resistor, I start pulling out the ohm meter, and usually they're pretty much time to just replace them. But okay, I'll secure that down. I'm using the center terminal as my ground. That's what the caps are. That's a 470 and that's 1,000. Here's another one of those carbon comps. This one's a 820 as well, according to the bands. It's gray, red, and kind of really dark red. But this one measures out at 1K, so it's definitely out of tolerance. So I'm going to replace this one as well. Alright, so here's an example of the bad caps I'm pulling out. These are the Sampo. See if I can get this in frame here. Sampo. These are 1 microfarad at 50 volts, and this receiver has probably over 20 of these caps in here. They're all over the place. 20 microfarad at 1 microfarad at 50 volts. Now, when I pulled it out, it had a little different reading. Let me heat it up again. I'll heat it up with my soldering iron, and we'll show you what the difference is with the readings. It's really temperature sensitive, these caps. So when I first pulled it out, it was reading something like this. It was reading 1.5 microfarad, 300 and some ohms ESR. But watch as it cools down, it just drops. This drops, and this climbs like crazy. So that is a really bad cap. That's temperature sensitive. It's way out of tolerance. It's a disaster in a circuit. So you can see it keeps climbing and climbing, and microfarads keeps dropping as it cools down. So as this cap heats up in the circuit, its value is going to change. Here, this is what I'm replacing it with. This is a 1 microfarad film cap, and it's going to be 993 nanofarads, 1.7 ohms ESR, and that's going to be stable. Why is it jumping up? Why did my ESR change? I guess I didn't have a good connection. Anyways, that's what I'm replacing it with. 2 ohms ESR, and pretty much right on the value. So when you got a receiver, when all these 1 microfarad caps, there's 14 of them in the power amplifier. There's one here, there's a few here, there's there's none on the phono stage, and I think there's one here, but they're all over the place, and they're going to change value when they heat up, they're going to change value when they cool down. Imagine what that does to the circuitry and the performance of this receiver. So I'm going to go through and replace all these dead caps with films, and we're going to get better performance, better stability. So I'm just going through recapping and finding little mistakes here and there. This is another one of them. So here and here I have 10 microfarad at 25 volts, I believe. Let me see. Yeah. And then here and here I don't. I have a 25 volt 10 microfarad at this position. This one here is this 4.7 microfarad at 16 volts. So this cap was put in wrong at the factory. These 4 caps should be, according to the service manual, they should be 10 microfarad at 16 volts. But for whatever reason they put 25s in here, which is fine. But this shouldn't be a 4.7, it should be a 10. So I'm going to put 10s in all these positions. Something like this can affect sound quality in one channel. I don't know exactly what it does, but it looks like it's in series with something. It's in series with this pin, and this pin, well, I can't see, is buried here, but I could have to trace it and see where it goes and where it comes from. That might be, well, there's a lot of connections between this board and the tone controls. So, you know, because they have the tone controls incorporated into this board. But yeah, I'm going to put all 10 microfarads in there. So it's things you got to look out for. Alright, so I pulled this 4.7 microfarad out, the one that was in there, wrong value. And I looked at the schematic, and guess where this one goes? This pin. This pin here goes to the back panel. To, what side is it? Left channel. Preamp out. So that capacitor was directly in line with this line here that goes into the power amplifier. Okay, this is a breakout here. And look what it reads on my meter. It is completely failed. It's 74 nanofarads, and it's got a 26 kilo ohm ESR. So that cap is done. Okay, so this board, it has graphics on it to show the traces on the top side, but there's no graphics as far as part numbers, orientation of capacitors. It's not marked on the board. So what I do is I pull one out at a time. For example, I'll pull this one out, and I don't have to take note of the capacitor orientation because I left this one alone, and it already shows me which way it's orientated. So the negative goes this way, and this one I put in the same way, negative goes this way. These are mirror images of each other. Well, they're not mirror images, they're actually duplications of each other. So if you forget, you pull your cap out and you forget which way it was orientated, I'm just looking at the opposite channel. And if you're doing one cap at a time, this is no problem. The film capacitors, it doesn't matter which way they're going in because there's no polarity to a film capacitor. But these electrolytics, they're all pointed the same way. Like you can see, negative is up this way, this one's up this way, so if I do this one, I know which I can go by the other channel. It kind of saves me time. Saves me time from digging through schematics and you know, diagrams of parts layouts and stuff, and I can get this done pretty quick. Alright, what you're looking at there is the main filter cap. That's the 2200 at 63 volts. What are they called? What's the brand of these things? Sanpo. S-A-N-P-O. So that's what's in there now. It's actually not doing bad. It's 27 milliohms ESR, which is pretty good. And it reads higher than its value, which can be due to leakage. Now I'm going to remove this cap and replace it with this one. This is a 6800 at 63 volts. Okay, that's going to provide ample supply of voltage and current for this amplifier. Goes here. This is the same diameter, 35 millimeters, so you'll just drop right in and make the connections and everything will look great. Now you probably wonder, well, you're jumping from a 2200 to a 6800. That's wrong. You can't do that. Well, you can do that. What I'm going to do is I'm also going to upgrade the rectifier diodes. These is a pack of 2 here, and I'll put some individual diodes in that are more beefier and are up for the task. And I'll get rid of this old rectifier. Now I'm pretty sure somebody's replaced these output transistors, going by this black crusty rosin flux. You usually have to heat a joint up 3 or 4 times and then you get this black rosin flux. It's really dried. So the original transistors, according to the service manual, is supposed to be 2SC 1061s. They're NPN. These are all NPNs. And somebody's put some RCA devices in here. So I'm pretty sure somebody blew the outputs. I've been having troubles with it anyways because they got the wrong fuses in the protection fuses are wrong size. So I'm going to get this cleaned up. I don't think there's anything wrong with these transistors. There's no advantage to putting them back to factory. Alright, so the output devices in this thing's RCA SK3054s. These are replacement transistors created by RCA, kind of like the ECGs. They are rated at 50 watts, 7 amps collector current. VCEO is at 90 volts and has a minimum HFE of 70. So these are actually up for the task. We just need to check them to make sure that they all have good gain, and if they do, I'm going to leave them in and let them run for however long they need to run. There's no point in changing these for, I was thinking maybe changing them for something modern, but there's really no point if the transistor is working fine and you know, the gain is good. So I'm going to yank them out and test them and see how they're doing. Okay, so I'm looking at this receiver and its design. It's an early receiver. Came right out of the era where they stopped using vacuum tubes and they started using transistors. This business of using printed circuit boards is a new concept, but they still hung on to their old values of wiring these things up. And I'm looking at this and I see a lot of opportunity for improvement. The power wires. These 2 wires here, this supplies ground to the speakers. This one supplies power to the both amplifiers. This wire, let's see here. Let's get a measurement on this wire. This is typically what's wired with solid core. And let's get a reading on this, see what size it is. So we got 25 thousandths of an inch. 25 thousandths of an inch. Here is 22 gauge. And it has a resistance of 52.93 ohms per kilometer. Maximum current 920 milliamps. I don't know what they mean by maximum current, but this wire here is inadequate as far as I'm concerned. A lot of things. I notice a lot of people don't talk about this in audio. It's not brought up very often, but these wires here need to be sized appropriately, and they're not. These are very undersized, and I think the performance of this would suffer because of it. So what I'm going to do is I propose to rewire this. A few areas, key areas, we're going to upgrade the wiring because this is ridiculous. So between here, this is a power wire, and here, that's where it ends up. It's a piece of wire. It should have 0 ohms, right? So let's check and see what our zero, how much of a zero it is. So let's connect our. Let's connect this here, and let's connect this one here. And you can see that we got 23 milliohms. 22 actually, because if I take my Kelvin clips and clip them together, oh, it does show 0. Look at that. So it's 23 milliohms between here and here. Now, between the star ground here and, let's say for example, this negative speaker connection, we've got 15 milliohms. So you see what I'm getting at? Let me draw you a picture. So let's just draw a typical power amplifier. We're not going to get fancy with anything. We're just going to draw the output devices and connect it together. Here's our speaker terminals, and here's our speaker. Let's say it's a speaker, and it's connected to this. Okay, now for power, we have typically a split supply, but it doesn't really matter. We have a capacitor here and a capacitor here that's feeding the amplifier. So what we want is we want this path here to have the least resistance as possible, because when this amplifier starts conducting and it wants to send energy out to the speaker, all that energy comes from the capacitors. Well, you might say, oh no, it comes from the transformer or not. No, it doesn't. It comes from the capacitors. The transformer, its only job is to keep it charged. Let me draw a bridge rectifier here. Here's our bridge, and here's our transformer. Okay, center tap to ground. So this path here, we want to keep the resistance of all these conductors as low as possible. Now, when the transistors are turned on and they start wanting to dump power to the speaker, this has to be as low as possible because we want maximum energy transfer. We don't want to have losses in here. We don't want to have 50 milliohms here, another 25 milliohms here, and another 15 here, and then another 50 here, and so on. And ESR of our capacitors is also important. We want to have a low ESR, we want to have a low resistance on all of the wiring on this power circuit of the amplifier. Also, you want to have on your speaker wires, you want to have at least number 16 gauge, but I usually go with number 14 gauge for your speaker wires to keep the resistance low. So this is not doing very good here. We got lots of resistance on these wires. We got resistance here. We got we upgraded the cap, so we have more better ESR on this. Now you notice this on a lot of modern higher end amplifiers. This circuit here, they pay a lot of attention to its resistance and its inherent resistance, let's call it. So what I plan to do is I'm going to rip out some of these 22 gauge wires and replace them with something like this. I think this is 16 gauge. You can read the wire here. Yeah, 16 AWG. You can see it there. So what I'm going to do is I'm going to rip out some of these 22 gauge wires for the power circuit. This wire here is ground wire, a few others. These wires, this pink and this orange wire, are power feeds from the fuses. I'll probably replace those as well because it's all part of the chain, right? And then we have green and blue speaker going out to the front panel for the speaker switch, and then back again to the output terminals. That's all wire in there as well. I'm going to replace 22 gauge with this 16 gauge. Just for example, here's what 16 gauge reads. I don't know what this is. It's over a foot long. But we can measure this as well. And you see we got about 6.5 milliohms on that piece of wire down from 23. And this is probably about the same length. This is probably the correct length I need just for reaching the fuses. Yeah. So I'm going to redo some rewiring here, get rid of all those milliohms, and see if we can't make this a little better. Okay, here's a good example of what I'm talking about with this resistance of the wires and everything else in the circuit too. It's not just wiring, it's the switches. So here's our two speaker outputs, the blue and the green wire. So let's try the blue first, and we'll go to the output of the amplifier. And if you look on our meter, if I turn the switch on, what am I missing out here? Definitely got the right channel, don't I? Okay, that is correct. Okay, there we go. So we're getting about 85 milliohms. Now that's the resistance between this point and this point. After it goes through the wiring and the switches, that's not very good. That's quite a big drop in that is a big loss for our signal. It's almost 100 milliohms. Let's try the other channel. I mean, this side looks like it's even worse. It's 403 milliohms. 800. Yeah, that's a dirty switch. 1.1 ohms. 1.4. It just gets worse and worse and worse. 90. Almost 1 ohm there. Let's try this channel. Same thing, it's 365 milliohms. If I work the switch, it really doesn't get better, it just kind of does random 150, 160. Let's go to this side. Same thing. Yes, so this is what I'm talking about. We need to replace these wires here come from the amplifier, go all the way around, and into the switch, and then they go all the way back to these outlets. So that's quite a bit of wiring. Probably over 1 meter long on each channel. And if you look at the chart here, 22 gauge, we've got almost 53 ohms per 1,000 meters. And what does that equate to? If we move the decimal place, it moves 50 milliohms a meter. So let me get this reworked. I'm going to clean these switches, and I'm going to replace some of this wiring for the speakers and the power distribution to these fuses and back to the amplifier. And we're going to get this beefed up a bit and performing a little better. Okay, let's have a look at these switches, see how hard they are to clean. I'm not going to remove them. I'm just going to carefully open this up. Without trying to break any wires off. These are all solid core wires and they don't like being flexed or handled. So let's put a little mark here just for okay. Let's lift this side up. Let's see how hard these are to clean. I think they're going to be a lever type switch inside. Okay. Yeah, that's what I thought. So we don't have any contacts, but what we do have is we need to clean this up. Okay. So I don't know if you can see, it's pretty black in here, but these contacts are silver plated. They need to be polished, and these need to be polished. These levers, and then we can reassemble, and it should be all good. So let's do that today, right now. So I'm going to use polish on the contacts. I'm going to use a very small amount. Not even a drop, probably too much there. Okay, where are we? Here. Just going to distribute this around. Okay, just get in there and work it. And you can see they start to come back to life. The problem with using polish is you got to clean it up after, so I'll go after this with some alcohol. Go after the center conductor too. Yeah, those are looking a lot better. Okay. Use a new one. Let's go after these. These ones aren't as bad. You can see the difference between them now. See, one's tarnished, one's not. Okay, that's good. Let's clean some of this up. Give it a dry buff. You can see how clean that is now. It was black before. So this is going to work. Okay, let's assemble this. Okay. That's getting hard for you to see. We'll put this on. This is what does the toggling. Alright, let's put this back together. Good. Now let's close it up. Okay, I'll complete this 4 more times on the other 4 switches, and then we'll see how that works. Okay, so what I did is I removed the original rectifier. This is a double rectifier. You can see in the end there it's got that, and then we can put these in. These are 6 amp diodes. More than good enough. Just going to put them in the original position, and then we'll solder it in, and then so that goes there like that. This one goes here. If I can get it in. This might be difficult. Let's see. Really got no room to work. Okay, there we go. Just like that, and I'll solder that in place so you can see that. Alright, there it is. After a couple hours yesterday, I rewired this thing, replaced all the power supply and ground wires with 16 gauge, and then for the speakers I used 18 gauge only because it was a little easier to work with, and 16 gauge is a little overkill. It didn't fit in the lugs. When you clean out the lugs on the solder points, you don't have room to stick a 16 gauge wire in there because it's too much copper. So I opted to go with 18 gauge, which is fine. This is all I yanked out. This is all 22 gauge, and this is all in the speakers, power, ground, and you know, that's the circuitry that was all wired with 22 gauge. So all this crap is gone. Oops. And it's been replaced with either 16 or 18. Now we're not done yet. We still can make some more improvements to this thing. I did upgrade the diodes to 6 amp, and I replaced the main filter cap with a 6800 up from 22. So there's 2 improvements there. We still have problems here on this board. Now if you look at this board, it looks like it was laid out with no thought as to current carrying capability. Some of these traces here are really pathetic. Look at how thin these traces are. They're like a millimeter thick. This one's a little thicker. It's all taped by hand probably. So what I propose to do is we're going to, so any of the traces that have to carry any amount of current are going to get beefed up. So we have our emitter and collector traces. We're going to beef this one up. This one already goes to ground. Emitter. And the collector. This is to the power supply. So we're going to do the same thing here, here. That's the base. Okay. Emitter. Collector. Alright, so these 8 traces we're going to beef up because these ones carry current. And some of them are pretty pathetic. Get these traces as well. The ones anywheres where we're going to have a high current flowing is where we're going to beef up these traces. And what I plan to do is I'm just going to use some of this 22 gauge wire I ripped out. It's solid core wire. We're going to strip it and we're going to lay it down over top of the trace and solder it. And that'll increase its current capabilities by quite a bit. I got my iron heated. Okay. So, let's do this one for example. This one here. Okay. Now, what I need to do is lay this down over top of the trace. We're just going to solder it in place. Yeah, that's exactly what I thought. Okay, I'm going to fight with this and I'll bring you back in and show you how I'm going to do it. Okay, that's what it's going to look like once you lay the wire down on top of the trace and solder it in place. This is easy because there's no solder mass to scrape off and it's fairly straightforward. Just got to make sure you don't have any bridges, any shorts. So I'm going to go through and I'm going to do the rest of these traces, the ones that carry current, and we're going to get this cleaned up. And then I'll clean the board, flux, and then it'll be done. It'd be much easier if I could see something without a camera in my way. Let's try this. Just trying to get it to shape to the trace. There we go. Okay. Let me tack this side down so it doesn't move. Should be using bare bright copper. This is tin stuff is not wicking very good. Okay. Now I can go here and drop solder on this trace. Nope. Okay. That part's good. It's going to flow solder all the way around and clean it up after. I know I got too much on here. This is where it's going to end. Okay. Now you just increase the current carrying capability of that trace by probably 2-3 times. These are very thin traces, and I don't think they're any good for maybe 1 amp. Not even. They're pretty thin. But once you do this, it beefs them up pretty good. Alright, I pull out these 4 output devices, and bad news, we got some really wonky results here. So the worst one's this one, 54 for HFE, and then 89, 92, and then 157. So yeah, got a problem. I think maybe some of these were getting a little hot. I'm going to replace all 4 of them, and my selection for replacing is a D44H1. And these are from ST Microelectronics. They're a good quality transistor. These ones are rated at 10 amps, 80 volts, 50 watts, 10 amps. These are a little bit different. Another good choice would be the TIP 41C. These would be these would be a good transistor to use as well. But I'm going to go with the ST transistors. So I'll get 4 of these out, and then we'll put these back in. Another thing about these, they all have an HFE of around 130. I can check them right here, right now. Make sure they're all the same. They don't need to be the same, but it doesn't hurt. That one's 129. First one I checked was 120 something. This one here, 126. Last one, 126. Okay, I'm going to put these 4 in. These are still good transistors, but they're, you know, the gain for matching, the gain is pretty terrible. Okay, I was looking at this old hardware here. These insulators, they're pretty poor shape. This one's all split, but a lot of these are crushed down, and it looks like they may have been overheated. They might have melted, and so we're going to garbage those. We're going to get some new insulators. We're going to use the old screws hardware. They're fine. So go with this like that. And then on the other side, I'm just going to use a self-locking nut, so that once you tighten it down, it stays tight. And I'll put this all together, and then we'll get her going. Alright, let's turn our attention to this volume pot. Now, I don't have a warm fuzzy feeling about this, because I think there's a dead spot on here, or a couple dead spots, from what I heard on the initial test. So this is a 50K pot. You can read it there, 50K times 2. And I got my ohm meter set up for reading that. So what do we got here? We got 50K right now. It slowly increases. This is turning it down counterclockwise. So, oh, there's a flat spot right there. That is probably right at the volume tap. Yeah, it's pretty close. Just keep going down. I'm just trying to see if I can spot which channel it's in. I can't remember. I think it was the left. Going down close to 0. And I hit the end right at 2K. Okay, let's do the other channel. Could be just dirty, but I didn't think so. It sounded like a dead spot. So let's try this one more time. Let's go up. Not seeing any dead spots. Right there it's flat. It goes flat when I, okay, yeah, that's the same spot as before. And it goes up to 50K. Alright, well that didn't show me anything. Let's take this apart and have a good look at it. Let's take the end cap off. Okay, we can't take this apart fully because it's mushroomed here and I can't pull the shaft out. I can take this end cap off and try that. Just if we can see what's going on inside. Looks okay. This looks all right. Just gonna get some neutral. Just gonna use some neutral 401B control cleaner. This has lubricant in it. Let's try this on here. Just want to put a little bit on and see if we're getting it's not bad. It's a little bit dirty. I think this might be one of those put it back together with some deoxit and hope for the best. Now another thing you can do if you have a damaged spot on your trace or your track here, so you can try if you have a spot here on your track that's damaged. This has 3 fingers on the wiper, so it's making good contact with the track. But if you have a spot where you have a dead spot on the track, you can try bending these fingers out or in just a little bit, like 0.5 millimeter, just so it rides on a new track or a new area, and it should maybe go by. It might go past that that dead spot. That's the last resort though. Best thing to do is just replace these things if you can find them. 50K. I don't know if I have anything in my stock. This has got the volume tap, and yeah, I don't think I have anything in my stock. So I'm going to put this back together. Wish I could remember which track it was on, with left or the right. Let's give this a little shot too. And we'll just work this. Guess I didn't need to take that off. Okay, I'll put this back together and see how it sounds. I'm also going to treat the balance pot and the two tone pots here as well. I'll take those and treat those. So I've been looking at the front panel of the frame and the front panel itself. You have all these foam blocks. They're probably on petrified like they are on mine. These are all, they were soft foam, but now they're all hard. Now these are all put here for light control. Now there's also this that goes across the switches. This was glued in place. I pulled it off. I'm going to tack this down with a couple of very small dabs of neutral cure silicone. I'll put that back on. Now there should be a foam gasket, or not a felt gasket, sorry, around the power button, and that's glued here for this. And then there should be another felt gasket around the headphone jack. Those are for light control as well. If this one's loose, pull it out and tack it down with some adhesive. This thing has all the original lamps in it except for the stereo lamp, which looks like it's the wrong one. Looks like it's out of a model railroad or something. Can't really see it. It's in here folded over. We'll this one here, I'm gonna look at that later. But one thing I want to mention is there was a block of foam here, and it was missing, and I removed the glue. You could see where the glue was. So what I did is I took some foam strips. You get this at the hardware store, and I sliced it down the center with a razor. And I'm going to take half of this, and I'm going to just place a foam strip right up here, just like it was in the original factory version. If I can get this peeled back. Bear with me here. I'm going to take half an hour or two, so just doesn't want to peel. Doesn't want to peel from the paper. I think I got it. Come on, baby. There we go. I just want to place this here just to block the light. Alright, and that is ready to go back together. Oh, this power button. You can see this. The one side is all cooked, and that was from the lamp, because the lamp is right here. It's less than a centimeter away, and it's cooking the plastic, and it's giving it that awful look. So I'm just going to turn it 180 degrees. I'm going to replace this lamp. I think it's burned out right now anyways. I'm going to replace this with a bright red LED. It's going to run cold, and it's going to provide a lot of light to come through that button. We'll get to that. Everything else has been done. Switches and pots have all been done. It's just a matter of cleaning this up now and putting it all back together. I don't see any issues with this at all. It's going to need a good clean. It's very nice condition. It's no damage. So that can go back. Alright, since I rewired the speakers, let's see what our internal resistance has turned out to be. I think I have this. Let's do this here. This is this channel. You should be able to see it up on your screen. don't know if this is the right one. Let's turn this on. Oh yeah, we got 28 milliohms. Turn it off. 29. That's actually a big, huge improvement over the few hundreds that we were getting. Let's do the other channel. There we go. 25 milliohms. 25 on that channel. Now in this channel we should get about the same. 22. It's even a little better. That'll go a long way to helping this thing sound good, is having a very low internal resistance. You know, before we were up around half an ohm or more. This channel we got 28. 28. Let's check this one. This one's high. We got 30, 37. Might still have a bit of residue on the switch. Okay, very nice. Now another thing I did when I rewired the speakers from the back all the way to the front, switches, let's see here, from the back all the way to the front, it came along here and it ran under this channel, or this side piece, and it was right alongside of all this mains wiring. This is all mains here, and everything that comes in on the power line, any hash or noise that comes in the power line, would get directly induced onto those speaker wires that went to the front to the switches and then ran back again. So I eliminated all that. I ran it right down the center. Power from the amplifier comes through this blue and green wire, goes down to the switch, comes back on the white and yellow, and the other blue and red here is the other channel, and then it goes back. So it completely avoids all this noise that's coming in on the power line, and that should go a long ways into helping with the clicks and pops that you sometimes hear when you're listening to stereo, and noises, hash noises coming in on the power line from appliances switching on and off. And hopefully that's going to do a service for us. Okay, we've got some power supplies to check out here. Our B1, that's our main supply for the power amplifiers. B2 is at 23 volts, B3 32, B4 is 19. I think there's B5 here at 30, B6 at 19 or 17, and B7 at 12. So let's power this up. I think you can see this. Got it plugged in. Turn this on. And it comes down to about 20 watts once it charges. Now I don't have the fuses going to each power amplifier installed, so there's no power going to the power amplifiers. This is just the remainder of the unit. So let's check voltages here. Get a ground going. So our main supply B1 should be right on the filter cap, and it should be, we got 48.5 volts, which is good. Now we need B2. B2 comes off of this 500 ohm resistor. It's a 3 watt, so that's this one. So this should be our 48 volts here. And this should be our B2. 22.3. And we got 23, that's good. B3 comes off of our main B1. It goes through an 820 ohm resistor, and it feeds this 2200 microfarad cap. But I don't have, oh, this is wrong. I don't have a 2200 here. I have two 1000s in parallel. Okay, and that is up here. These two caps. Here's our 820 ohm resistor and our two 1000s. And then this pink line is our B3, I believe. Yeah, B3, 32 volts. Okay, I can check that here. And we have 32 volts. Okay, good. That feeds the early stages of the power amplifiers. B4 is 19. Comes off a where are we? 500. Goes to 500. Goes through a 470 and a 220 cap. I don't know where this B4 is. $500. There's a 220 cap here, but there's a 2.2K, and that's 16.5 on that 220. This cap here is a 220. This big one, and this little one's a 47. This 47 should be our B5. What? 500 to that 47. This 47 shows 22 point. Okay, that's the direct connection between here and here. Okay, that's this 47. Goes through a 270. Where is this? I'm going to have to flip this over because there's some resistors and caps on the other side. Hang on. Now some of this doesn't match because I'll turn the power back on. Because some of these values of resistors, for example, this 270, I don't see it here. I have a, oh, there is a 270 here. Okay, let me check this one. This one is ground. The meter back in the picture here. This one's ground. This one should be the 22. And then this one here is our, looks like 11 volts. It should be 12 volts, which is good enough. This one here is 16.5. That is a 1000 microfarad. That might be our B4 or B6. 680, yeah, okay, 680. B6, 17 volts, and I'm measuring 16.6. It's good enough. Okay, what I'm going to do is I'm going to power up these amplifiers with my bench supply. I have here, I got 40, 48, 45 volts, and I got it current limited to about 120 milliamps. So let's connect one of these up at a time. And let's turn the power on. It should draw. Let's see what it draws. Okay. We're at 48 volts. We're drawing 8 milliamps. That tells me everything's nice and healthy. And consuming about 0.4 of a watt. So let's do the other channel. Shut that off and let it drain down. And let's try the other channel. Okay, powering up. Okay, same thing. 8 milliamps. Oh, we got 0 milliamps. Why do we got 0? That's not cool. And check my connection here. Might have a fault in this one amplifier. Try it again. 11, 10, 9, 8, 0. Why is it shutting off?
So this is just made out of styrofoam.
So we might have a problem with this one amplifier here on this one side. Let's try it for a third time. And let's see, 11, 10, 9, 8, and then it goes 0. Something's up. And that's this amplifier here. So we're going to have to maybe do some troubleshooting on this one. I'm not sure what's going on. I don't know why it's shutting down. It could be that it's set, the bias is set so low that it's not consuming any current, but I don't think so. Should consume something. Alright. So I think we're safe to put these fuses in and power this up for the first time. Okay, I got a couple amp in it, 1.5 amps. We're going to put these in and then we'll power it up.
All of these little items that are on the shelves.
Okay, I think I'm ready for first power up. It's plugged in. Let's plug it in. And let's got a tone fed in.
Now we're going to go to an Adobe house.
Okay, tape monitor was out.
I think I'm going to bring the light over.
19 watts.
How am I going to do that? Can I?
Consuming power.
Can I easily do that?
Both our channels are good. Left and right. Treble. Bass.
Did you build this Adobe house, Holly?
It's our phono. It's quite noisy. Ouais, je crois.
Vous êtes pris depuis 2 ans, c'est...
Somewhat on the outside here. The flower fine or I made.
Monitor source. Mono stereo. Should be stereo.
Insolvency with Faber. Becoming debt-free is possible, and a personal bankruptcy or a consumer proposal will get you there. Schedule your free Faber focus session at faber.ca today. You'll learn how a consumer proposal allows you to eliminate your debt by paying a percentage of the amount owed without interest. At Faber, we'll tackle your debt.
What's better than getting a small premium roast coffee and your favorite McMuffin? Getting a small premium roast coffee and your favorite McMuffin for only $4 plus tax, starting March 5th, only at McDonald's.
Alright, everything's working. We still need to troubleshoot a few things. Let me set this amplifier up, and I don't think anything's getting hot, nothing's warm, everything's perfect. So let me set the balance and bias, and we'll focus our attention to the tuner.
Of the Lord forever. Music to live by. AM 9. Global News.
Students in an Alberta town that had banned pride flags and rainbow crosswalks from municipal property say they are heartbroken. But looking ahead, a slim majority...
Yeah, heartbroken. Okay, AM's working good. FM, we still don't have FM stereo. Well, that's probably an alignment thing with the multiplex or the IF. You're getting signals through. AM's working pretty good. And I think we're getting on the path of being finished here. Okay, time to set up the amplifier. It's a little bit convoluted procedure. Set balance, bass, treble control to center position. Set mode switch to stereo. Speaker switches on. A selector switch to auxiliary. Connect an 8 ohm load across the resistor, or across left and right speaker output. And then connect an audio generator, 1000 Hz tone to the auxiliary input. Okay, Rotate the volume control clockwise, position full volume. Increase the generator output until the sine wave on the scope just starts the clip. Adjust DC balance. VR 501 for equal clipping on positive and negative half cycles of the signal. Now, the potentiometer they're talking about is these big ones here, and then there's a couple of two tiny ones here. It's kind of confused as which one's which, but I think I got it figured out. The big ones are the ones we're going to focus on. And then we do that for the one channel and then the other, and then adjust crossover potentiometer VR 502 until the crossover notch just disappears. Rotate the volume control counter clockwise position to get 100 milliwatts, or adjusting the idle current using a DC voltmeter parallel of R918. Okay, we set that for 10 millivolts. So you can do it either way. You can adjust it so the crossover notch disappears, or you can use the current meter, measure the voltage across the resistor to measure current. And then yeah, do for both channels. So let's turn this thing on, and let's feed it 1000 hertz tone. I think I got it set up. Yeah, there it is. Wow, that bottom trace doesn't look good. Looks like it's got some oscillation or something in it. So let's do one channel at a time here. Not a very good balance pot. A pretty poor balance pot. Okay, which one are we going to do first? I think we're going to do this one first. This is left channel. Let's go up in volume until we hit clipping. And it looks like we got clipping equal both top and bottom already. Yeah, we do. So I'm going to leave that adjustment alone. Let's go to the other channel. Let me set my trigger. Our trigger on channel 2 right now. And if I go up, yeah, it's got a little imbalance there. So let's adjust this for clipping on both the top and the bottom. Maybe I got the wrong channel. Yeah, I do. Had the wrong channel. Okay, so we got equal clipping top and bottom there. Let's turn it down a little bit. I think we're good. Okay, now I got to go back and fix the other channel that I messed up. Okay. Right there, I think. No, a little bit more. I'm just tweaking the volume pot here, and it seems like it's doing it a little early on the bottom. Right about here, I think. Yeah, right about there. Okay, let's check the other channel again. Looking good. Okay. Alright, I think we're set. So let's do our power test while we're here. Let me turn it to clipping. Going with the top trace, and that's full power right now. Start our timer. And we have 10.24 volts RMS on the output. Actually, the right channel is a little bit weird. Turn it down just a touch. I'm going to have to readjust that right channel. Don't think it's there yet. Turn it down a little. Now we're at 9.5 volts RMS. Seems like our left is a little weaker than the right. Just by a slight amount. We've got a little slightly more gain on one channel. Let's let this go for 10 minutes and see how it warms up. It's already getting... Okay, we're at the 9-minute mark, and I'm just going to take some measurements here. Everything's pretty cool. Power transistors are barely up at 50 degrees yet. I think the highest one I measured was 50. Yeah, there's not much happening here. There's not much heat. No, it's just starting to get warm. These drivers, they're cool to the touch. They're not warm at all. They're just ambient. And everything else is running pretty good. The emitter resistors, they're around 40. Yeah, not much happening here. Pretty lazy day. Now, I want to measure the rail voltage. At full power, we're getting a lower rail voltage, so let's get this in the camera. So I think we're getting quite a bit of sag in the power supply. Let me measure here at the input. And what do we got? We got 34 volts, down from 48, I think it was. If I switch off the speakers, you can see this will jump up to 47. Now we're at 34 again. So, not a very stable power supply. It's the transformer's probably just at its maximum. The rewiring we did probably helped quite a bit with that voltage drop. It probably reduced it by a fair margin. So this has been going on for about almost 12 minutes now, and nothing exciting happened. We're still at about 9.7 watts, or 9.7 volts on the output. So I'm going to shut this down and call it test a success. Okay, I just discovered the lamp is out, and that's kind of odd because it was working when it came in. Now it's out, but it's not the right lamp. Now I measured, this is a 12 volt 40 milliamp bulb. This is the one I'm going to use, and I applied it in the circuit and it turned it on. Stereo beacon's working, the lamp comes on for stereo, but it's very bright, so I measured the voltage across it, 20 volts. And I was reading in the manual here, if you look here, it says 14 volts 80 milliamps, and this is even less, but it takes quite a bit of current and it's taking quite a bit of power. So To knock that down, I'm putting a 150 ohm 2-watt resistor in place in series with it, and then we can reinstall this. I think I'm going to get rid of this lump of heat shrink as well, just so that we can make it a nice clean installation. So I'll get busy on that, and then I'll put this lamp in, and then I think we're pretty much done. So I've had to retap a couple of these holes. They're totally mangled, these threads, and I'm just chasing these through, and I don't know what the hell they were doing, but some of them were mangled, and then I got some new hardware for some of this because some of them are missing. So okay, we still have a problem with the multiplex circuit. I'm getting poor performance through that. Now, the original complaint was that I had the stereo light was always on, and if I connect an antenna, I got no antenna now, but if I connect an antenna, you can see that light comes on, and it's just reacting to background static, so it's not working properly. Now, if I go through the band,
Nail in my heart.
it appears to be working. But I'm getting no stereo separation. I can't hear it.
Street, there was a restaurant who had decided to have live music. So Saturday nights, I sang at supper hour.
This should be
In
stereo.
1939, she moved to Vancouver, where she...
But the fresh slicing doesn't stop at beautiful Black Forest ham.
And I can't.
Turkey, perfectly piled pepperoni, sensationally sliced salami, so you can lunch.
So I'm not getting separation, and we're still not getting proper behavior out of that. So what do we do? Okay, I've just been spending the last hour chasing my tail here, looking at the multiplex circuit and not seeing anything wrong with it. And I'm beginning to believe there's nothing wrong with the FM stereo. The FM stereo is working. This is more of a global problem within the receiver itself, because what I'm doing right now is I'm feeding a signal on, where are we here? Feeding the signal on the left channel on the tape amp auxiliary input. Tape amp auxiliary input right there. Here's my tone. Now if I go to left channel, I hear a tone, right? Because I'm feeding it left channel. Center, right channel. Something is blending the two channels together. It's a little bit louder on the left than the right, but it's definitely the left is getting through onto the right side somehow, and I think it might be a bad balance pot or missing ground or something like that. Connecting this to the right channel. Okay, here we go. Right channel, center, left. You notice how it gets louder in the center? And it's in both channels. Now I noticed that when I first started testing this, did the first initial test, I noticed the sound was quite loud in the center, but then when you went left or right, it got less in amplitude. Something is going on with this. Okay, there's only really two connections between the channels. One of them is right here in the stereo mono, and that is not the problem. I checked that. Now, the other connection between the two channels is the VR903. This is the balance control. The center tap of that potentiometer is grounded. Alrighty, I think I just found the problem. There's a broken ground wire here between these two boards. Now, this is not broken from me flexing the wires. This is broken from it pulled out. It was a cold solder joint, and it pulled out from the board. So I'm going to put this back together, solder it. That would make sense because this ground is applied to the center post of the center point of this pot, and that should prevent the left channel from bleeding through to the right channel. And then when you switch it from one side to the other, you're attenuating one of the other sides. So yeah, let me solder this back together and we'll do a quick test. We should be okay. No signal connected. Let's turn it on and give it some volume. Okay, here's right channel, left. Perfect. Now if I connect this to the left, we get our signal back. If we go to the right channel, it's gone. Okay. Okay, I'm gonna wrap this one up. This has been a tough one. The alignment especially was really, really frustrating. I actually went through the alignment yesterday and I was not pleased with it, so I slept on it and came back at it today with a fresh mind and attacked it again. And I think I got it a lot better this time. It's not perfect, but it's usable. And as far as the rest of the improvements I made to it, well, time will tell. I have a feeling it's going to help quite a bit. I should have taken some before and after measurements. Would have been the smart thing to do, but pleasure to listen to it for a couple weeks just to hear how it sounds. So the big story for this one was, again, dead caps. As far as that goes, I'm going to end this here. All right, so thanks for watching and keep tuned in because there's lots more coming. Again, thanks for watching. Talk to you later.